Dear viewers, welcome to another video on the series of MINITAB tutorials. In this video, we are going to see another graphical representation of MINITAB, which helps us to identify whether the data collected from a sample or from a population follows symmetric distribution. So the name of the plot is symmetric plot. So if I click on graph, if I click on stats, quality tools, we have something called symmetric. So what is a symmetric plot? Determine whether your data are symmetric. So first of all, let's understand what do we mean by symmetric. So let me open the whiteboard. So we all know normal distribution is also called as bell curve, right? And why it is called as a bell curve? Because it resembles the shape of a bell, hence it is called as bell curve. So if you see this, if you assume this is a normal distribution, for a normally distributed data, the mean, median, and mode will fall in the unique peak. It will fall on the center. So your mean, median, mode will all fall on the unique peak. Right? So somewhere in the center. So a data which is symmetrically distributed is where you have the right side and left side of the data being a mirror image of each other. So equal amount of variation or equal amount of distance that the data is uh, available on the right side as well as on the left side of the median. So we can take the center line as median. So this nature is what we call it as symmetric distribution. So normal distribution curve is symmetric, not only normal distribution, even if you take an uniform distribution, which would look something like this, and uniform distribution will also be symmetric. So we should not misunderstand a data which is symmetric is always normal. That's not the case. A data which is symmetric may be normal, may not be normal, but being symmetric is one of the characteristics, right? So why this characteristics is important? Let's understand. Because some of the hypothesis testing that we do, for example, if I click on stats, if I go to non-parametric test, and if I say non-parametric test, an equivalent of one sample t-test is one sample Wilcoxon test. Determine whether the median of a sample differs significantly from a specified value used when the data are symmetric. That means what? I can use one sample t-test if my data is normally distributed. But if my data is not normally distributed, then I cannot use one sample t-test. Instead, I need to either use one sample sign or one sample Wilcoxon. These are two alternative tests. Within this alternative test, Wilcoxon can be used only for a symmetric data. So what is the underlying meaning? A data which is not normally distributed can still be symmetrically distributed. So whether it is distributed symmetrically or not is what we are going to see now using this symmetric plot. So here I have some example data available. So first we will take this excess weight team A as an example. So this is in a cement company where people pack cement bags, right? How much weight is extra? So this is the data. So if I go to stats, quality tools, symmetric plot. So I had totally 30 data points. So if you see here, I have totally 30 data points. I select the symmetric plot and then I say OK. When I say OK, if you see here, there will be 15 data points for which the dots will be plotted and there is a red line. So you may wonder when you have 30 data points, why only dots are plotted for 15 data points. So we will keep this aside for some time and we'll understand how this symmetric plot as a graph works. Then we will come back to this. For some time, we will go back to our Excel. So here is my symmetric data. Sorry, here is my excess weight data. So what I'm going to do with this excess weight data is to start with, I'm going to arrange this data in ascending or descending order. So let me do it in ascending order. So data, sort. So let me go with only the current selection criteria, right? Smallest to largest. So what happens? Here I have 30 data points, right? So let me take this 30 data points separately. Maybe paste it here. So what I'm going to do is I'm going to have these 30 data points here. So 1 to 50. And then I'm going to create another column which will say 16 to 30. So I'm going to break this data. So this entire 30 data points is first sorted in an ascending order, right? I have taken data point 1 to 15 in this column. I have taken data point 16 to 30 in this column. And once I do this, I'm going to again sort this second set of data in descending order. That's the reason why I do this. So if you see this data, this is the smallest value of this 30 data point, and this is the largest value of this 30 data points. In other words, this is the minimum and this is the maximum. So you can understand this data starts from here, comes down here, then it goes this side and then goes here. This is the maximum. Now what I'm going to do is I'm going to calculate the median. I'm going to calculate median for this 30 data point. So I can go to this 30 data point. The same 30 data point is what we have here. So the first question that I ask is, how far is my minimum value from median? It is 4.34 units away. Okay, great. How far is my maximum data point away from median? And it is 2.96. So let me take it to maybe 3-4 decimals so that we will be able to compare it easily with MINITAB screen. So this is the distance of my minimum value. So I can call it distance from minimum, and this is distance from maximum, both sides. Right? Okay. So now what I'm going to do is I'm going to freeze these cells. Right? Median cell I'm going to freeze. So now it is very clear that 9.73 is 4.33 units away from the median, whereas 17.03 is only 2.95 units away from the median. So if you consider median as the central data point of a given data set, then the minimum value is far away from the median and the maximum value is not that far away from the median, right? So if I want to explain this, so I have my median somewhere here. My minimum value is this much far away from the median, whereas my maximum value is only this much far away from the median. So automatically what we understand is the data is not having equal variation on both sides. The data is not having equal variation on both sides. So that is what we are understanding with this set of data, right? Okay. Now what we will do is we will now complete this exercise. Right? So for the extreme values from both sides, we are seeing how far it is away from the median. So on one side, it is far away from the, okay, this side I have to freeze myself. Yeah. So if you see here on one side, the values are quite far away from the median, whereas on the other side, the values are not that much far away from the median. So that's what we are seeing on this particular case. Now what we will do is we'll go back to the MINITAB screen. And if you keep your mouse pointer here, this is nothing but our very first data. The unit is 4.33, or this particular pair of data is 4.33 units. Its maximum value and minimum value we are comparing here. The minimum value is 4.33 units away from the median, whereas maximum value is only 2.95 units away from the median. If you see here, 4.336, 2.957. So that is the same data that you are seeing here. So for the 30 data points, we are plotting it in such a way that we are checking how far is the data point away from the median, the extreme values on both sides, how far are they away from the median. And you can very clearly see here, the lower distance to median is very high, whereas the upper distance to median, you don't see any data point this side. That means this data is skewed on one side, this data is not symmetric. That is the meaning. This data is skewed on one side and this data is not symmetric. Now, what we'll do is we will have another data which is weight of cereal in a box. So we will take this data and we will bring it to MINITAB and we will again perform the symmetry plot. So I'm pasting the data here. stats, quality tools, symmetric plot. Now I take weight and click OK. So what does this tells you? This tells you there is a lot of data points more or less have equal distance, the median from the minimum value and maximum value. The data points are somewhat equally distanced. And that is why if you see this, there is a slight amount of skewness here. But then if you see, these are the data points which is contributing to that. Otherwise, up to this point, maybe up to this point, this data is very much symmetric. So a symmetric plot tells you whether there is equal variation on both sides. And normality test tells whether your data is normal. Symmetric is one of the characteristics of normal distribution. Not necessarily all symmetric distributions are normal. Non-normal distributions can also follow symmetric distribution. That means equal variation on both sides. And for our statistical analysis at various stages, we may have to check the characteristic whether my data is having symmetric distribution, even though it is not normal, whether my data is having symmetric distribution. In such scenario, we will be able to use this plot, and how this plot works. I have explained it using the Excel. I have also explained it how to interpret this graph in MINITAB. I hope this video was useful. See you in another MINITAB tutorials video. Thank you for watching.